reality modern workplace is about ushering in the next evolution in computing and productivity.
Work has a very different definition as we move into the digital revolution, where work means thinking and creativity and collaborating with others.
I think the modern workplace is changing and it's affecting everyone. Why wouldn't we want to make people's jobs better when we can?
Mixed reality allows us to find new ways to express creatively and also problem solve creatively.
Information workers have been pretty well supported by technology over the past 3 decades, but there's a lot more that we need to do to support how the workplace is changing.
More and more today, people are working remotely. They're not all located in the same physical building. Imagine being able to change the people you're meeting with, the place where you're meeting, or the content that you're collaborating around, all in a matter of seconds.
It really unlocks new possibilities for the way that information worker can be productive. Inherently saying you want a PC on every desk implies that people have desks. But we know that there's a huge part of the workforce that actually don't have desks. In fact, we think 80% of the workforce are what we call first-line workers, and we think they number over 2 billion worldwide.
When computers have the ability to understand the real world, a bunch of really powerful things can happen.
We've been looking at the critical workflows for the first-line worker, and we are committed to bringing products to market to help them do their jobs more effectively. One of the first critical workflows that we uncovered was for the field service worker who often needs to call in for some expert help. With mixed reality, we can bring the expert to them, and the expert can see what they're seeing and can annotate into their space and help them solve the problem and verify that it's been done correctly. Another critical workflow that we've uncovered is around training employees on new products, processes, equipment. Companies are spending a lot of time and money on this today, and these things change often, and they're so critical to their operations. Another area of opportunity is around space planning. Companies need help designing and planning out their spaces efficiently. Mixed reality enables them to view their designs with digital objects, and they can see them at scale, and they can walk through them and iterate before they have to make the costly decisions.
And I think all those things come together to sort of shape what this modern workplace looks like as we go forward. Digital transformation is really impacting every industry, every company today. And the companies that we see that are most successful at digital transformation are those that empower their employees and rethink the employee experience all the way from the boardroom to the information worker and then onto the first line worker.
In the past, Microsoft has focused mostly on providing us with ways in which we can do more. Now we're starting to entertain ideas of what it means to achieve more, and that by its nature has a certain amount of value associated with it.
And this has inspired us at Microsoft in the work we do to create products and services that will empower people in this new world of work to do their very best work, to solve real problems, and to achieve more.
It's the obligatory logo shot. So what I'm going to talk to you about a bit today is how this whole thing works, how it all comes together. A little bit of analog gaming stuff for you there instead of digital. For those of you who don't know me, actually, have any of you seen me present before? Excellent. I can use all my old jokes. So my name's Rocky. I do work for Microsoft. I'm part of our Mixed Reality Studios team. So we do a lot of the first-party apps and a lot of the apps directly with customers that work on mixed reality for HoloLens, MR, AR, all that. So I'm going to talk to you a bit today about how that comes together and how we can enable you to also be able to do this. Okay? Now, we've got this system where you think of your ideas and you have your two-dimensional applications and things, and you know you want to get to this total end-user experience. You know you want to get to a point where you've got this application. You want me to really talk into here, don't you? You really? Okay. All right, so video guy, okay, and audio guy now. Now we're on live. I got to be careful what I say. Okay, so we're going to do this and be able to help you get from A to B. And there's some pieces in here that we want you to kind of use that's going to accelerate this considerably. Now, if you look at some of the parts that are in there now, we basically have these two different sections that we're putting together. One is the MRTK, which is the toolkit, and the other one is the MRDL, which is our design labs. Because what we have found is one of the hardest things for people to get their head around when it comes to mixed reality is how to interact with the physical space, especially if the physical space is going to change. Because this is something you don't have to deal with in AR or VR. In AR, the physical space is almost irrelevant because it's a 2D overlay, and if the thing moves or not, your overlay stays where it is. In VR, things don't move unless you tell it to, right? Give you an example. Holographic water bottle. I'm wearing my HoloLens, I have my holographic water bottle, and I put it on the lectern. While I'm wearing my HoloLens, I go out there and do some other stuff with it. While I'm gone, they come in here and they take the lectern out of the room. When I come back into the room, what happens to the water bottle? What is it? It's still there. It could still be there. Might not be great experience having it floating in the middle of space. But now we have to deal with that kind of stuff. And that's a challenge that we don't have to deal with in things like VR, because you're not going to let anybody take the lectern. Or if you do, you know exactly what you're going to do with the water bottle. But it could be as simple as not displaying the water bottle. And the explanation is, I'm going to assume that the water bottle went with the lectern when they took it. Easy to explain, but it's a design pattern that we haven't had to deal with until now. So we have our design labs that help you with some of these UX and UI decisions and how to think about holographic applications. Well, we also have this mixed reality toolkit. Now, both of these are open source, available on GitHub. The training is all free. The labs are free. You can download all this and build on it or wherever you want to do. And I'll show you the links to that a little bit later. But the toolkit itself is the widgets and the pieces you're going to use. Now, over the past 8 or 9 years of us developing holographic applications, we found that there's a set of things that is really common that we're using all the time. So you can memorize this. There's going to be a test in a few minutes. No, things like keyboard, buttons, bounding boxes, all that kind of stuff. How do you do anchoring? How do you put something in space and have it stay there versus follow you around? So holographic locking. All of these things holographic applications need. But instead of rolling your own, now we've got this toolkit that you can download and just use. So we've plugged in that middle piece, the MRTK. Now, can you guys read that? No, you're not supposed to be able to read it. But it's on GitHub, and you'll be able to go to GitHub and download everything that I'm showing you today. Okay? All right. So one of the things we've got in here is, next slide. You can do it. There you go. Is these app bars, bounding boxes and app bars. Every holographic application is going to use this at some point, especially if you want to allow the user to resize or manipulate anything. So instead of trying to create this on your own and giving them, here's where you anchor your vision, here's where you grab and stuff, the grab handles, it's much easier to drop in a bounding box behavior on your game object and just turn it on. And then it just works. That all happens for you in the Windows Mixed Reality platform. Buttons is another one. The app bar is the bit you see on the bottom, the 2 buttons down there. A lot of things are going to be changed depending on the context that the user's operating in. So sometimes you may want them to have a pinch and drag gesture that may rotate something. Other times you may want that to move something or to be a slider. Well, those app bars help you overload those actions to get to that point. Another common we found is two-handed manipulation. It's a very natural gesture to do this, to stretch something out, right? Well, now that's all enabled in here. When you add this behavior to your game object, it will automatically enable two-handed manipulation for you. So you don't have to write all the extra code for that. And we're very committed to doing this kind of stuff. Our mixed reality studios, there's about 150 people that do holographic applications all the time for us. And every time we come across something that is repeatable, something we know we're going to use over and over again, we're going to add it to this mixed reality toolkit for you. So you'll see this expand, and you'll see a bunch of stuff being added to this over time. Another one, these holographic buttons. One of the things we always look at is how can you tell which one you're on? And that box that pops up around it and the glow, that's something we've seen where when we implement it that way, it's very easy for users to adopt and to understand how that operates. Magnetic cursors is another one, where when you get close to a button, the cursor will kind of snap to that thing. Because we discovered early with things like HoloLens, if you're using head tracking as your cursor, where you turn your head to put the cursor on something, your head is not near as steady as you think it is. And a lot of people, your eyes make up, they compensate a lot for this. But if you try to put your head on something and hold a cursor steady on a very small spot, it's actually quite difficult. So we found that by using the donut, a larger cursor with a circle in it, it's more like a targeting reticle. And then doing magnetic cursors, people are able to pick up targeting really quickly. And it makes it a lot easier for them to do. So the app bars, the glow, the frame, and magnetic cursors really, really help in creating a UX that users can adopt. Another one is the standard shaders. Now, in holograms, people want them to look sci-fi and holographic and all that stuff. So we found that by doing some material work and some shaders, adding some built-in shaders for you, we can do the edge glow, we can make them look semi-translucent, we can make them look like frosted glass. But this shader we've developed, you drop it onto your game object and you just change the settings to get these effects. So you don't have to recreate your own textures and shaders to do this. You can drop this one in place, and it pretty much fits the holographic paradigm. How we're going to do this and what things are going to look like, including some of the clipping planes and things that are built into some of these shaders. All right. How many of you have done any, or your companies have done like their own kind of shader creation for apps like this? You've done some. Do you sell your shaders? No? Okay. There were some on the Unity store we saw where people were doing some of these shaders, but we found they weren't as efficient as the ones we had built. So anytime we're going to add new shaders to this, we'll just drop it in the toolkit for you. So you just do a git pull and update your git repo, and you'll get these new shaders. Another thing we've been looking at is how to get this to you guys and how to make it available. Because even if you get this toolkit and you have this system, if you don't know how to use it, it's going to be a struggle. You're going to be hunting and pecking and trying to figure out how everything goes. So there's a batch of tutorials that goes along with this. When you do the Git repository, when you pull the information, you're going to get the tutorials. You can do individual components, and there's example code and example scenes to show you how to do all of these things. So you don't have to worry about just struggling to figure it out. Just follow the tutorials. Now we also have a thing called the Mixed Reality Academy, which is, I was trying to remember how many tutorials are in there now. There's 60 or 70 tutorials on doing holographic applications now. And it's not just for designing the app and the scene and the game objects and the models itself. It's also for things like connecting to cloud-based systems. How do you take a holographic application and connect it to Azure or Amazon or something like that? The other thing we've done, and it might be in here a little later, so I'll talk about the remoting in a minute. But we wanted to make sure that even the commercial aspects of this, you're able to adopt very quickly. Okay? Now, fortunately, in fact, there it is. There's some of it. If you guys use Slack, you can join our Slack channel. You can do feature requests for us on GitHub for the repos. But we want you to be part of that community. We want you to connect with this. You can do a pull request. You can add to it and submit it. We do review it before we put it into the system. So don't put weird things in the comments, which has happened. But go ahead and do it. File issues. Try it. We hope you want to adopt it. The other thing, I just talked about that part. Submit a pull request. Do that. Now I'm going to put this last one up here and just talk for a minute. So when you're building these kind of applications, when you want to get out there and you want to experiment and explore a bit, we want to help you. We want to make this as easy as possible. Because one of the things we've done with Windows Mixed Reality is we've made it work across AR, MR, and VR. And so far, the Windows Mixed Reality platform is the only one that does that. Now you can work on Vive and Rift. That's excellent. Because every time you build something for a Vive or a Rift, there's a great big Windows 10 machine that's powering it, which we love. But those tools are by necessity VR only, the way they're built. Even the Rift Go is a VR tool, which is kind of interesting when you think about it, because now that you're not tethered to a computer, and you have a thing on your face that doesn't let you see the environment, and you start to walk around, you might have some problems. But with our system, with Windows Mixed Reality, we can operate on things like this device, the Surface Go, which has AR and MR capability in it through its depth sensing camera in the back. So even if you create a holographic application for something like HoloLens or VR, I can view it on my Surface Go just by holding it up and looking at it. And if I want, I could put my HoloLens on and have that application be an MR experience that even integrates with the surface reconstruction around me. Or I can use one of our third-party hardware devices with the immersive headsets that are VR style and load the application in that and have a VR experience. So by building with Unity and the Windows Mixed Reality platform, you pretty much get the whole range of hardware options that you might want to use. And that helps quite a bit. Instead of recreating code bases or having to maintain multiple code bases, which can get very convoluted. Even if you've got a great code management system, that process can get very, very convoluted. So by being able to build for one platform and get all those hardware form factors, it's a huge advantage in being able to scale. And when you're thinking about using this kind of stuff to get into the commercial side of the house, there's companies that you may work for that may need applications built that may need a training application that is very VR heavy. Because training in VR is actually very immersive. And numbers are starting to emerge now that data retention and training ability improves by anywhere from 40%, if you believe Pearson, all the way up to 1,200% if you believe, keep forgetting the name of the report, Entity Stats or something like that. So this is a very attractive option to get into fairly early, is just building training applications. And it's all based on gaming technology. You know, people say, oh, I want to be a gamer, I want to write stuff for games, I want to use gaming tools. But the commercial world actually has really steady paychecks, right? It's not you're working on a hit title or you're unemployed. So using those skills and the same tools and creating the same kind of stuff in a commercial environment can be very attractive, actually. The other thing I wanted to mention real quick is stuff like holographic remoting. Now, how many of you have seen some of our stage demos or seen videos of our stage demos with HoloLens? And you've seen the special camera, the guy walking around with the 85 pounds of camera gear so you can see what they see in the HoloLens. Well, we have changed and modified that system to be, you can do it in two ways. We've open sourced all the gear, and you can 3D print the ring that mounts on top of your DSLR, and you mount the HoloLens to that. So you can record your own through a DSLR. We tell you how to set up the computer and the recapture cards and all that. Or you can use the MR toolkit and use the iPhone remoting so that you can take what's in a HoloLens and transmit that to an iPad or anything on iOS. So someone can be wearing a HoloLens and you can hold up your iPad and you can see what they see. And you can record that way as well. It's really good for recording quick demos or samples of what you're building so people can see it. You just have to make sure that when you create your apps, you create a multi-user experience and you put the MRTK in there and then transmit to the iPhone. So it's actually pretty simple to get multi-user experience with people who don't have HoloLenses. You do need one HoloLens in the mix because something has to do the surface reconstruction and anchor the holograms in place. But then you can have multiple people viewing it on Surface devices, iPads, other HoloLenses, VR devices, or whatever. So we're enabling that as well. And we are either just about to release or are working on the Android version as well. So as you might have known, our new manager, CEO, Satya, he's very much about, if it's a computer, our software should run on it. So we want to help you do that as well, which is why we're doing stuff like that remoting. All right. We got started a bit early. I think I'm way ahead of schedule, which is good. People like being ahead of schedule. Now, I'm happy to chat and answer questions in as much as I can. There's a couple questions I will absolutely dodge, but I will answer as many of them as I can if you want to ask any.
You're talking about collaboration, shared experience before. Are you talking specifically about remote collaboration or co-located within the same room? Does it work for both?
Okay, so we're talking about remote collaboration before, and does it work if they are in the same room or remote? It depends on the application, how you want to build it. If you're going to do the iPad version, the iPad needs to be able to see the anchor points and to pretty much set it up where the HoloLens says it is, and that tends to be in the same room. But you can set up holographic remoting and do a remote, not holographic remoting specifically, that's a specific app, but you can set up a multi-user experience where you do not have to be in the same room or even in the same country. So in the video I showed at the beginning, some of you might have missed that, there was a picture of Case Western Reserve University where they were looking at a brain, a holographic brain. And there was also a picture of some people looking at a retail store layout. A couple of the people in that video showed up as avatars, kind of like a blue or purple avatar. They were in different buildings or different states when they did that. And you do that simply, with a HoloLens it's easy because the HoloLens knows where it is in relation to the hologram. So it can transmit its location in relation to the hologram to somebody on the other side of the planet. And then the person in Texas can look at it, and the HoloLens will draw the avatar of the other person in relation to where it is in relation to the hologram. So that's actually not as hard to do as it sounds. So you can do either one, but the iPhone thing, it needs to kind of be in the same Wi-Fi network area. Otherwise, what happens is, let's say the person with a HoloLens has a table in front of them and they put the hologram on a table. If the person with the iPad's in some way somewhere else, they're going to hold up the iPad and there isn't going to be a table to anchor it to, and it might just be halfway through a chair or something. So you have to be cognizant of that kind of problem, but it would be possible, yeah. In fact, your counterparts in New Zealand at Trimble have done some of this with the SketchUp viewer.
Yeah, that's right.
Yeah, so they can help answer how they did it for you internally as well, because they've done that with SketchUp viewer.
Yeah, we're exploring it as well. I'm from the mining department.
Okay.
And we're doing visualization.
Yep. Yeah, that's come up a lot, actually. Holographic computing or MR computing for mining. Medical mining, automotive, and engineering and training are the top ones we get. And mining is fantastic because let's say you've got a tunnel-based mine, which looks like an anthill. You can pull it up out of the table and look at it from the side and trace things, zoom in on a section and see what the ore might be. Like you look at a wall, say this is 15% gold ore. You can do gas, natural gas mining, oil mining. Yeah, so it's a lot of good visualizations in there. That was a long answer to a short question, but yeah.
We had problems before with the collocator. I was experimenting with it, and I think it lost the anchor position, so it drifted quite a bit when you...
What was the receiver? Was it an iPad? Was it iOS or was it another? Were you using peer-to-peer or did you have a server? Did you send the anchor points to a server? Okay. So peer-to-peer might drift a little because of just the raw compute power in the HoloLens device. If you try sending it to a server, which could be just a laptop in the room, it might be a little more stable. Try that. Have a kind of a third-party location server.
Although we experimented like a while ago, like a year or 2 years ago.
Oh, okay. Update it. Yeah. We've done a lot. Like RS5 for HoloLens released 2 nights ago, night before last. And that has a lot of improvements, including stuff like Miracast streaming, and there's all kinds of improvements in it. So update the devices. In fact, update the devices and just try it again. See if that doesn't help it just with the update. Yeah.
Are there any specific like classroom because currently we've got the equipment, but it's just that students
Right.
just, they go everywhere around to look for information and at the end of the day, there's no specific area to go.
Yeah, we haven't specifically developed university-level curriculum or classroom-based curriculum beyond the Holographic Academy. But we have worked with other universities like RMIT in Melbourne. So you guys have some in Melbourne. You have some, yeah, where it was developed by RMIT based on the stuff in our Holographic Academy. And all that stuff in Holographic Academy, feel free to use it. I mean, download it, use it in-house for training, build your own curriculums off of it. But if you talk to the guys in Melbourne, they've got some. If you send me an email, if you can't figure out my email address from this information, I don't know what you've been doing. Send me an email, and I will connect you with the guys in Melbourne that have it. Yeah.
Do you think anytime soon we will be getting eye tracking in the HoloLens device?
Do I think if anytime soon we will be getting eye tracking in the HoloLens device? Is that a good answer? I really don't know. To be honest, that comes up a lot. But the thing about HoloLens, it's very close to your face. And so for eye tracking, I mean, there's ways you could do it. You could put the camera by your ear and use a mirror, right? But that tends to get in the way. I don't know where that is on the feature list. It's on there. I know it's on there, but I don't know how far down the list it is. So if I gave you an answer, it'd be wrong. So we are aware of it. It is on our list. I'm not sure when it's going to be addressed.
How about improvements to the field of view?
Improvements to the field of view.
Yeah.
If I had a dime for it. Okay. That is definitely on our list, and it's very high on our list. Stay tuned.
Do you have any timeline for it?
If I gave you a timeline, they would make a liar out of me. Maybe within a calendar year. But don't hold me to that because I don't control the timeline. But that is way up on the list. Way up on the list, like maybe number 1 or 2.
So about the 3D reconstruction that you showed,
Yep.
is it from the depth sensing or stereoscopic rendering?
Yeah, so the way we do we call it a surface reconstruction. The way we do that is through depth sensing cameras. If you've seen the front of the device, which I think one of these, I think you can see it in this, oops, not that one. You can see it in this image fairly well. See that camera right here? If you can see that? There's one on each side of the device, and it uses stereoscopic vision, the same way your eyes work. It uses parallax and depth perception to reconstruct the surfaces in the room. So that's how we do it. It's optical. And then we do a surface reconstruction, and all of your holograms or your game objects interact with it. They're colliders. We turn it into a bunch of planes and polygons, and we make them colliders in real time for you so that you can interact with the SR. It's infrared assist. There is infrared involved, but it's primarily these depth sensing cameras out here that do it. Yeah. So it does work better in low light than your eyes will, but yeah. Did you have another one?
Yeah, I wanted to ask, would there be like upcoming versions of HoloLens where it's a bit cheaper and or easier?
Cheaper, faster, lighter, better.
Yeah. Because currently, like, it's hard to access. Like, we buy one and we, get the students to use it. Like, there's $3,000, So
Only 3? Where are you buying them?
no, like,
3,000 US dollars,
Yeah,
yes. Yes, there is another one coming. Yeah. Again, we don't have a release date.
all right.
It won't be too long, but there is another one coming, and we've tried to make improvements across the board. That's what we're aiming at. Those are the elephants in the room, right? Okay. What else?
We have issues with rendering dynamic meshes, 3D models coming from the server. It causes slowdowns in the HoloLens.
Yep.
Lagginess, do you have?
You are probably somewhere near 90 to 100,000 polygons, give or take. Yeah. That's about the practical limit you want to try to do, because the GPU on the HoloLens is a mobile GPU, and it's gonna have to render all that. So the way to solve that is pre-render. Now you can render on a server, and once it's rendered, you can stream that to the HoloLens. It's what we do. Like, have you guys seen the NASA demo, where we've got the surface of Mars and the guy's looking at the surface of Mars? So we do that with that information. We pull information from the Curiosity rover. Well, JPL does. It's their stuff now. We pull LiDAR imagery and high-resolution photography off the rover, and then we build the mesh out of that, stretch the picture over the mesh, and pre-render it on a box called mSplice, and then the pre-rendered image is streamed to the device. So if you do the actual rendering off box and then stream the results to the HoloLens, you'll be fine. But the HoloLens has a practical limit of around 100,000 polygons per scene that it will deal with. So that's the way we solved it. But that's just a pure horsepower issue, really. What else? This is your chance. I have to go to another meeting after this. I'm actually pretty impressed. For Southeast Asia, there's been quite a few questions in the room. Like when I did Unite in Korea, nobody asked any questions, and when I was done, everybody rushed the stage. You guys know the 8-second rule? Not that it matters too much here. Here's the 8-second rule for presenters. When you say, are there any more questions, you're supposed to count in your head. And if you can get to 8 seconds, there aren't any more questions, or nobody will ask them. Because apparently 8 seconds is an uncomfortable silence. And at that point, if someone's got one, they're going to ask it. If they don't, they won't. Okay, anyway, I'm finished. If you're finished, I can hang around for a few minutes. I'll put this back up here in case you do want to email me. And again, if you can't figure out my email address from this, but please let me know. This is my patch. I cover biz dev for a big space. Pretty much anything from Japan to India and Korea to Antarctica, I cover. So I'm the guy you want to talk to for stuff around Singapore. Okay? Thanks for coming in and chilling out with me. It's nice and cool in here.